Namaste everyone, hope all of you are well. Today we are going to discuss lecture number 2, equilibrium, chapter number 7, class 11 chemistry, lecture 2nd. In the previous lecture we have discussed about the concentration of the reactants and product, and we have find the value of constant. Let's do a little bit revision of the previous video. That at the end of the first lecture what we have studied. At the end of the first lecture we have discussed about the rate of reaction. Means if we talk about the A plus B was a chemical equilibrium, C plus D, this was R1 and this was R2. As I had told you that about the rate of reaction is directly proportional to the concentration of the reactant, right? So we have done also, I hope that all of you have remembered, R1 is directly proportional to the concentration of A and concentration of B, and R2 is directly proportional to concentration of C and concentration of D. Have you remembered? In the previous video at the final steps we have studied about this all. So not an issue. Here the concentration was M1 and here it was M2 and here it was N1 and here it was N2, right? Have you remembered or not? Here this was M1, M2, N1 and N2, right? So not an issue. What we have done, R1 is equal to K. This was a forward reaction, A to the power M1 into B to the power M2. Here it was a concentration and R2 was backward reaction, so constant here C to the power N1 and D to the power N2, right? And after understanding the constant, then what we have done? What we have done here, since R1 is equal to R2 at the chemical equilibrium, right? So here what we have done, Kf, concentration of A and concentration of B is equal to Kb, concentration of C and concentration of D. Have you remembered? And after that what we have done? Here the concentration of, here we have just taken the concentration of forward and backward reaction, and here we have written the concentration of product upon the concentration of reactant, right? In the previous video we have discussed about these all the things, if you may have remembered them. And what we have done about this, the ratio of forward and backward reactions, we have just put here that the ratio of constant of forward and backward reaction, we have taken a K. What is this K? Can you tell me? This K is known as equilibrium constant. K is known as equilibrium constant. So here what we have taken, the concentration of product upon the concentration of reactant, right? So this was our previous video, that what we have studied, if you may have remembered that, right? So this was the concentration. Here K is known as equilibrium constant or equilibrium constant. Now after understanding this, here the K has some definite value. If I talk about here this K is Kf by Kb, means forward reactions constant and backward reaction constant. So the equilibrium constant can be of the two things, means one will be for concentration and another will be for partial pressure. If you can ask me, sir, what is this partial pressure, right? Here you can ask me, sir, why we are adding this partial pressure? Because the things what we have studied in the previous lecture is the reaction constant. So here it is just a ratio of forward and backward reaction. So if I talk about the concentration of equilibrium, so here you can write forms of K. K is what? K is the constant of forward and backward reaction. So here for a reaction, if I talk about forms of K, there are two forms of K. One is for concentration and another is for pressure. One is for concentration and another is for pressure. If we talk first for concentration, so in the concentration, you know very well, we will take a reaction, that equilibrium A plus B is equal to C plus D. So here you know very well, for the concentration I am taking, okay. So here M1A, or we just write a reaction without doing these all the things. Directly you can write a reaction here. This is equilibrium reaction as we have seen here. Correct? So if I want to find the concentration of this reactant, so what will be the value here? Can you tell me what will be the concentration constant? Here it will be the concentration of the product upon the concentration of the reactant. Right? This is the concentration constant. If I ask you what is this Kc, and here if I talk about the SI unit, the SI unit will be mole per liter. Mole per liter. And if I talk about the pressure, here, then pressure constant I have to find. Kp, as I have here written, the concentration constant Kc, similarly I have to find the concentration of Kp. So there is nothing else. What we have to do, just instead of this N1, N2, here it is a molecular, so that's what we have, we are a constant pressure we have to take. No need to worry about this. So here everything will be according to the, as Kp value will be concentration and the constant pressure, it will be here at the constant pressure of the products upon the constant pressure of the reactant. Right? So here, as you have seen, the forms of concentration or forms of the constant in the terms of concentration and the terms of pressure. Now if I ask you what is the relation between this Kp and Kc, what is the relation between this constant pressure and constant concentration? What is the relation? Can you tell me? If you consider a reaction, then you will get the value or relationship between the constant pressure and constant concentration. So here, just consider a reversible homogeneous chemical equilibrium. We have to consider a homogeneous chemical equilibrium. Right? Or you can just understand this is the homogeneous equilibrium constant. Okay, understand this reaction as that here the homogeneous chemical equilibrium reaction M1A plus M2B at the equilibrium. Here the rate of reaction, I don't want to mention it, I just want to write here. Now I want to show you the relationship between the Kp and Kc. What is the relationship between the Kp and Kc? Okay, so not an issue, no need to worry, as you can see here. Okay, so what is the value of Kc? Kc value is the concentration of product upon the concentration of reactant, right? And here if I talk about the concentration of at the constant pressure, Kp value. So here the concentration of product at the constant pressure upon the concentration of the reactant at the constant pressure. Right? Now can you tell me what is the ideal gas equation? Have you remembered the word ideal gas equation? If I talk about the ideal gas equation, you may have remembered that PV is equal to nRT. What is this? Ideal gas equation. This is ideal gas equation. Right? If you may have remembered in the chapter number 5, then P is pressure, V is volume, N the number of gaseous molecules, R that is universal gas constant, the value is 0.821 liter per mole per Kelvin, and the T is temperature. So now here I don't want to tell you more and more thing. The molar concentration of active mass is N by V, that is molar concentration of active mass. What is this? Molar concentration of active mass. Okay, So now here the P is equal to N by V RT, right? Can we write this or not? Yes or no? Definitely we can write. And here if I talk about this N by V, that N by V is nothing else, it is the molar concentration of active mass. So can you tell me here, what will be the value of PA and PB and PC and PD? Yes? Instead of this, just suppose this is equation number first, this is equation number second, this is equation number third, and now by putting here N by V, this is the concentration. This is nothing else, it is a molar concentration of active mass. So here, in the terms of Kp, yes, in the terms of Kp, so what can we write? PA value, PB value, PC value, PD value. So can we write here? Just suppose about the concentration of A, and PA is equal to, since N by V is molar concentration. What is N by V? N by V is molar concentration. So here what we have to write? PA is equal to AR, the concentration of reactant. Similarly, if we write PB, then PB is equal to concentration of BRT. Similarly, PC is equal to concentration of CRT, and similarly PB is equal to concentration of DRT. This is, what is this? A concentration A, B, C, D, these are nothing, these are the active masses, molar concentration of active masses. So that's why here I have written also N by V is equal to molar concentration of active masses. Now if I talk about, here as you have seen, that PA, PB, PC, PD value. So if I put this value in equation number 2, just imagine that what will be the values if I put here, these are all the values in equation number 2. Okay, so now keeping this value PA, PB, PC, PD, all the values we are putting these values. Just suppose this is your equation number 4. Okay, now putting the values of equation 4 in equation 2. Okay, so we are just putting Kp is equal to, instead of PC, what we have to write? CRT, right? Can we write here? CRT. Instead of PD, we have to write DRT. Instead of PA, we have to write ART. And instead of PB, we have to write BRT. Can we write this thing or not? Yes or no? First tell me. We have just put the values. What we have done? We have just put the values. Now, here, after understanding the concept, what we have to do? We have to just write here the N1, N2, M1, M2. Okay? So now can you tell me, this RT will be the cancel, right? RT cancel, RT cancel. So the values are concentration of product, similarly as it was earlier, upon the concentration of reactant. Right? Can we write this value? Yes or no? Yes, we can write. So now here you can see the concentration of the product values. If you multiply this concentration with the values of RT, means what is this? You just see, we have just taken the values from equation number 4 and we have put into the equation number 2, and what we have got, that is our equation number 1. What is this? This is our equation 1. Is this the same equation 1 as you can see? So what you have got the value, can you tell me? Here as we have just removed the RT. Now question, if I talk about you can cancel or not cancel, but if the values are, RT values are having some concentration like N1, N2, M1, M2, then we can't cut these values. So directly if the concentrations are there, Okay. If I talk about the concentrations, then what you will write here? RTN1, RTN2, RTN1 and RTN2. Right? So here the value, whatever you are getting, that is nothing else. The value here is RT N1 plus N2 upon RT M1 plus M2. So here the value you are getting Kc into Rd. So can we write here that therefore Kp is equal to Kc into RT N1 plus N2 upon RT M1 plus M2. So here what we have written, just you can see the concentration of CN1, DN2, concentration of AM1, BN2 and RT N1 plus N2 upon RT M1 plus N2. So what we can write here, this is the value of Kc, right? This is the value of Kc. So can we write here Kp is equal to Kc RT to the power N1 plus N2 upon RT to the power M1 plus M2. And you know very well in the power and exponent that we have to put this M1 plus M2 in the minus side. So what we have written, Kp is equal to Kc RT N1 plus N2 minus M1 plus M2. So you know very well what is this N1? This is nothing else. These are the number of gaseous molecules. So delta Ng is equal to N1 plus N2 minus M1 plus M2. So here instead of that delta Ng, here we can write that Kp is equal to Kc RT to the power delta Ng. Kp is equal to Kc RT to the power delta Ng. Here if I ask you that the Kc is expressed in the SI unit will be mole per liter, and here Kp will be expressed in the atmospheric pressure, means atmospheric to the power delta Ng. Now just suppose that when the delta Ng value will be 0, here all the things you have understand, just take a click of this board, and after understanding the concept, now we will move towards that how this delta Ng value is varying. If the delta Ng value will be 0, then what will be the value of this Kp. Okay, all of you have taken a screenshot. Now let's move towards the equation. Just suppose here that when the delta Ng is 0, there are many cases which rises delta else. What will be the value of this delta Ng? So here, when delta Ng is equal to 0, what will happen? Then Kp is equal to Kc RT to the power 0. Right? You know very well anything to the power 0 is equal to 1, right? Anything to the power 0 is equal to 1. So here it's means this RT to the power 0, it's right. Here remember this delta RT to the power Ng, delta RT to the power Ng. So what will be the here? Kp is equal to Kc when delta Ng is, remember, so I was asking you the relationship between the Kp and Kc. So Kp will be equal to Kc when delta Ng is 0. If I talk about when the value will be negative, if you want some example of this concentration of, or you can say constant pressure or constant concentration, then I can give you some examples also, no need to worry. Just suppose N plus O and nitric oxide. So here if I talk about the number of gaseous atoms, or you can say just that N2 gases, O2 gases, so here 2N. Is there any doubt in this equation? No doubt. And you know very well this is also in the gaseous atoms, right? And what will be the NO? NO is in gaseous or solid liquid? Which phase? It is in the gaseous only. Okay. Now can you tell me here, what is the value of Kp and Kc? The value will be equal. No need to worry, the value will be equal. Similarly, if we talk about the hydrogen, just suppose that molecular gases and I2 also, if it is so same, nothing else. Okay, so but don't forget to write the physical states. Okay, so here when the Kp and Kc are unitless in this case, if anybody will ask you what is the unit of this Kp and Kc, so in this case Kp and Kc are unitless, because the delta Ng value is 0. Got it? So after understanding, when you are taking the delta Ng value 0, now when the delta Ng value is positive, okay, now I am taking the delta Ng value as a positive. Okay, so now can you tell me what will be the changes in the value? I hope you know. If we are taking the value of delta Ng as a positive, just suppose that this value I have taken positive. Can you tell me what will be the value of Kp and Kc? Kp will be greater than Kc or it will be less than? Just tell me the value, nothing else. If we are taking the delta Ng value as a positive, then I hope that you know Kp will be greater than Kc. Yes? So here Kp will be greater than Kc. Am I right? Because we are taking some values of delta Ng and delta Ng value is positive. So in this case, if you want example, then you can take PCl5. Okay. So PCl5, can you tell me how this PCl5 turns into PCl3 and Cl2? All are in the gaseous. And the equation is chemical equilibrium. These are the examples of when the Kp is greater than Kc, or you can say the delta Ng value is positive. Okay, so Kc unit will be here. What will be the value of? That's mole per liter, and Kp value will be atmospheric pressure. Similarly, if we talk about 2NH3, okay, so what will be there? N2 plus 3H2, right? So here also the same thing. When the delta Ng value is positive, that time we can write these type of reactions. So I hope that now you have understood about the positive and negative value. What will happen in the negative when Kp is less than Kc? Means when the delta Ng is negative. Here just delta Ng is negative. Can you tell me what will be the terms of this delta Ng when negative then? When the delta Ng is negative, that time just reverse the reaction. No need to do anything. Here just reverse the reaction. As for example, PCl3 plus Cl2 is PCl5. All are in the gaseous state. Similarly, in the NH3 also, N2 plus 3H2 is equal to 2NH3. Right? So remember the SI units. If anybody will ask you what will be the concentration here, so Kp is in the atmospheric and Kc in the mole per liter. I hope you have understand about these things. Now the special point, if anybody will ask you that, sir, what will be the value of temperature here? Temperature value, remember, at a special point, T will be 1 by R. T will be 1 by R. Now here if I talk about the Kp and Kc, then instead of nRT, okay, so here the Kp and Kc value, here you know very well, Kp is equal to Kc RT to the power delta Ng. So instead of T, what I have taken? Instead of T, I have taken 1 by R. Right? Instead of T, what I have taken? 1 by R to the power delta Ng. Right? So RR cancel, that is Kc 1 to the power delta Ng. Can we write this thing? Yes or no? Can we write or not? Definitely we can write. So 1 to the power Ng, it will be 1. So Kp is equal to Kc. In this case also the Kp will be equal to Kc. Remember, for any value of delta Ng, the Kp will be equal to Kc. And the constant pressure and the concentration constant. Remember, no need to worry about. If anybody will ask you, sir, what are the applications of this concentration K, where they are being used, then you can tell them there is the stability of reactant and product. There is the stability of reactant increases when the value of K decreases, and the stability of product increases then when the value of K decreases. So it is the stability. If I will ask you, what is this? Use the stability of reactant and products, when it will be increased, when it will be decreased. So as the stability of reactant increases when the value of K decreases, and the stability of product increases, so value of K increases. Reactant increase, K decreases. Reactant increase, constant decreases, and the product increase, the concentration also increases. So now I hope that all of you have understand about these special points. Now the factors affecting the equilibrium constant. What are the factors which affect this equilibrium constant? And I am telling you, first of all, the things which affect the equilibrium constant is temperature, as that I have changed R into 1 by R. Yes? So here if I ask you, what are the factors that are temperature? The value of equilibrium constant change with the change of temperature if K1 and K2 be the equilibrium constant of a reaction at the absolute temperature T1 and T2, and the enthalpy change is the change in enthalpy, then log K2 upon K1. Then at the constant, that means if we are changing the temperature, then log K2 upon K1. Just I am showing you that how these values are being changed. What affects just understand the concept. Log K2 upon K1. Now you can ask me, sir, where is log K2? Means I am just talking about the factors affect the equilibrium constant, and log K2 upon K1 will be delta H upon 2.303 R 1 upon T1 minus T2. What will be the value? Delta H. What is this delta H? Enthalpy change upon 2.303 R into 1 by T1 minus 1 by T2. Okay? Where the factors affecting the equilibrium constant, if I am talking about the temperature, then what will be the value of this? Or if you want to change this value, means directly you know very well here that instead of log K2, we can write here log K2 minus log K1 is equal to change in enthalpy upon 2.303 R into 1 by T1 minus 1 by T2. Can we write this thing? Yes or no? Just tell me. Definitely we can write. This is according to the Van 't Hoff equation. Remember, if the temperature T2 is higher, if T2 is greater than T1, if T2 is greater than T1, then what will happen? Then T2 minus T1 upon T1 into T2 should be greater than 0. Remember the word. It should be greater than 0. Now question is, if I talk about the standard enthalpy change, and if I talk about the standard enthalpy change, now if I tell you that if the standard enthalpy is positive, when it will be positive in which reaction? Endothermic or exothermic? I hope all of you have remembered in the previous class I have taught you when the enthalpy will be positive. Endothermic reaction, the enthalpy change will be positive, and in the exothermic, the enthalpy change will be negative. So here, if the delta H value is positive, then what will happen? Positive means, you know, it is greater than 0, right? So here, if it is greater than, means log K2 upon K1 is greater than 0. Or you can say log K2 minus log K1 is greater than 0. So here you can write log K2 is greater than log K1. Can we write this thing? Yes or no? Definitely we can write K2 will be greater than K1. Right? We can write these things? Yes or no? Definitely the value of equilibrium constant increases with the temperature increases in the case of endothermic reaction, and in the exothermic reaction it will be decreased. Similarly, as we have taken in the increased form, similarly we can take in the decreasing form also. So here in the terms, the value of equilibrium constant decreases when the temperature decreases. Now after understanding these all the things, the mode of representation. Now mode, how we will represent the equilibrium constant. Now in the forms of mode we are representing. Now equilibrium constant may be represented as the concentration of the product upon the concentration of the reactant. Now we are representing in the forms of mode. So equilibrium constant Kc is equal to the concentration of product upon concentration of reactant. What is this? Can you tell me? These are modes. Square brackets are also known as modes. Equilibrium constant is represented. The reaction is reversed. If the reaction will be reversed, then what will be the equilibrium constant value? Can you tell me? If the reaction is reversed, the reaction was A plus B equilibrium C plus D. And if I reverse the equation, C plus D equilibrium A plus B, then what will be the value of equilibrium constant here? There is no need here. The equilibrium constant inverse is equal to concentration of A, concentration of B upon concentration of C, concentration of D. So no need to worry. Equilibrium constant inverse, the value you can see. So here if anybody will ask you what is the relationship, so no need to worry. Kc is equal to 1 upon K inverse C. Means it is inverse. Okay, so the two equilibrium constant can be related to as here. I hope that all of you have understand about this concept. Now we will go ahead after understanding this multi-step reactions, stoichiometric reactions. I just want to ask you that if I will take any one reaction, can you write the equilibrium constant? Yes or no? Just tell me. I just want to give you one example. All of you understand this concept now? Now just take a example that how you will represent these things. It's very easy to represent. Just suppose NO2. Equilibrium. What will be the equilibrium? Half N2 plus O2. Half N2 plus O2. Okay? This is the equilibrium constant. Now can you tell me what will be the value of Kc? Kc value you know very well. Concentration of the product. So N2 concentration to the power 2 O2 and upon and O2. Can we write this thing? Yes or no? Just tell me. Yes, definitely we can write. If the reaction will divide by 2, what will happen? If the reaction 1 is divided by 2, what will happen? If this is your reaction 1, if you divide 1 by 2, okay, this equation 1 you are dividing by 2, so half NO2 is equal to N2 plus half O2, right? the reaction will be like this, and here the inverse reaction, you can say that Kc will be that product. Here you can see N2 is there, right? Product N2 is there, and here N2 to the power half. If the reaction is dividing, if you are a reaction dividing by 2, then what will happen? Okay, not an issue. Just suppose that this was your reaction, okay? So what we have done, now you are dividing this, or you can just take a reverse reaction. Just suppose that reverse 2NO2 is equal to N2 plus O2. Multiply the equation 2, okay? Multiply by 2. So 2NO is N2 plus 2O2, right? The reaction will be like this, yes or no? Yes or no? Yes. So can you tell me what will be the value of Kc? Kc will be the concentration of products upon the concentration of reactant. Am I right? Can we check this equation? Yeah? Yes. See, just we should know how to write the reaction. In the next video, I will show you about these examples, that how you should write the reactions. The concentration of the reactants we will write in the next equation. The stoichiometric of the reactions I will show you in the next video. And if you want to learn something, then you have to understand the concept. It's very easy. Just remember that what you have to do. You don't have to forget anything. You are taking any reaction, किसी भी reaction को लेना है, और reactions के जो आगे में जो multiples होते हैं, coefficient जो होते हैं, उसको power बना देना है. Concentration में जैसे हम लोगों ने starting में किया था, यहाँ पे coefficient A का, B का, C का, D का, तो coefficient को क्या करना है? In the terms of exponent we have to express it. Okay? So that's all for today. The point we have revised today: the concentration of the reactant and product, volume, presentation in the inert material, pressure, and the presence of catalyst. Now in the next video we will describe what the degree of dissociation. That's all for today. Thank you very much. Hope all of you have enjoyed. If you have enjoyed, then don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. That's all for today. Thank you very much.